Hey guys, in this video we will be interfacing the 24lc256 EEPROM chip, which stands for electrically erasable programmable read-only memory. So we're going to be interfacing this with the Arduino Uno. So let's get started. First, obviously you want to connect up the power rails to the Arduino Uno, and then first the breadboard connection. So place your chip on the breadboard. Connect pin 1 to 4, all of them to ground. Pin 1 is A0, pin 2 is A1, pin 3 is A2. So you want to connect up all of them to ground, and obviously pin 4 is the actual ground. So you want to connect up all of the first 4 pins to ground, and then you want to connect pin 8 to the positive rail because pin 8 is VCC, and you want to connect pin 7, you want to connect it to ground. Next, the Arduino connections. So you want to connect pin 6. Let's see here, pin 6 goes to A5, I'm assuming that's SCL, and then pin 5 goes to A4, I'm assuming that's SDA. Since this IC does use I2C protocol, so let's get to the code. So in the code, the first thing we want to do is include the wire.h library because we're using I2C protocol with the chip. Next, we want to define the EEPROM I2C address, and since we set those 3 pins which are A0, A1 and A2, since we set them to ground, the address in hexadecimal for this chip will be 0x50. That's the hexadecimal value. So we want to say define EEPROM I2C address as 0x50, and then an int address. So which address do we want to store something in? I'm just taking it as 5 in this example. And then we want a byte called data, and it's a byte obviously, so it can go from 0 to 256. I mean 0 to 255. So I'm just using 1 here in this example. So I've made 3 functions called write data to EEPROM, print data to EEPROM, and there's another one, read data from EEPROM, which is right here. So let's go over each of those functions one by one. So the first one is write data to EEPROM. So we say void write data to EEPROM with 2 arguments. For the first one is an integer address, and the second one is a byte data. And then the first thing we do in all of these functions, basically the first thing we do is say wire.begin, and then we say serial.begin, and then the baud rate, you can choose whatever you like, but I'm choosing 9600 here. So in all of the functions, the first 2 lines will be wire.begin and serial.begin with your baud rate. Okay, so after that we say wire.begin transmission to the EEPROM I2C address that we defined earlier, and then after that we say wire.write integer address shifted to the right 8, and then we say wire.write int address bitwise and with the hexadecimal value FF, and then wire.write data, and then wire.end transmission, and then we have to keep a delay of 10 seconds, otherwise it just won't work for some reason. And then the next thing we say byte read data from EEPROM with the first argument as an integer, and we call it address or add for short. And then I told you, right, the first 2 lines will be wire.begin and serial.begin, and then we say byte read data is equal to 0 and then we say wire.begin transmission to the EEPROM I2C address, and then wire.write int address shifted right 8, and then wire.write int address bitwise and with the hexadecimal value FF, and then wire.end transmission, And then since we're reading it now, we say if wire dot avail, no, we say wire dot request from the EEPROM I2C address, and we request 1 byte from there. And if we say if wire dot available, then we read data, we set it to wire dot read, and then we just return data, as you can see here. And then in the next function called print read data, so we say void print read data, and then it's a long int address, and then wire dot begin, and then serial dot begin, like I said. And then we say byte read data is equal to read data from EEPROM, and then we say the address, which is a parameter or argument that we made in our function print read data just now. And then we say serial dot print. I'm just using this kind of format. You can just print the address or the read data. I'm just saying serial dot print in double quotes address space, and then I'm printing the actual address, and then I'm again printing serial dot print in double quotes space colon space, and then I said serial dot print ln read data, the variable, and then again we have to delay 10 milliseconds or else it just won't work. And so that's it for the code, and obviously we call those two here. So after doing all this, we set the int address and byte data, and in the loop you don't need to do anything, but if you want to, you can put some stuff in there. But we just called write data to EEPROM in the address that we created over here and the data that we created over here, and then we just print read data from this address that we created over here. So let's plug it in and see if it works. So here I plugged it in, and let's upload the code and see what the serial monitor says. So let's upload it and see what happens in the serial monitor. Okay, it's uploaded, and as you can see in address 5 it stored a 1. So basically you can set these two variables to whatever you want. So we wrote to this address, we wrote the data, and we read with this address. And since it's a EEPROM, even if you unplug the power and you plug it back in, it'll still be stored. So that's it. Okay, bye.